Good morning or afternoon or evening, whatever it is where you are. My name is Charlie Chemistry. Oh, hello, Charlie Chemistry. Yeah, I'm gonna teach the kids all about playing with chemicals and having fun. Oh, that sounds good. You want to hold up the sign that says what we're studying this week? Oh, yeah, and simple machines, too. Here we go. Chemistry and simple machines. Oh, I don't know what to talk about first. They're both so exciting. Oh, yeah. Well, why don't we talk about our little simple science experiment book? All right, here. Oh, Miss Anna, they can't see me. Hi. Okay. So, in this little booklet, there are some really fun things to do. You can make magic soap. All you need is water, oregano, and dish soap, and it shows you how good it is that soap gets germs off our hands. Then we have, hot rocks. Hot rocks is fun. You just get rocks, and then you heat them up in the oven with a grown-up to help you. And then you get out some crayons, and again, you have, oh, that's kind of hard to hold in my mouth. Excuse me, I was talking to them. Okay, sorry, didn't mean to interrupt. Anyway, what were you saying, Miss Anna? Oh, you just, the crayon melts on the rocks, but you have to have a grown-up help you with this. It says, caution, parent supervision required. Do not touch hot rocks or ouchie. Ouchie, I know what that means. Okay, next experiment is what, Miss Anna? Oh, the marshmallow shooter. I don't know if the parents are going to love this one, but it's another way to recycle toilet paper rolls, but you do need some marshmallows. And the next experiment, oh, so much fun. This is called marbled milk, and what you need is some food coloring, some dish soap, and some milk, and it makes these beautiful patterns. Oh, that sounds fun. And the last two are making milk into plastic, and that is requiring some milk and vinegar and some more food coloring. And the last is something you've probably seen before, the erupting volcano with baking soda and food coloring. Because when things mix up, they can change and make other things. Let's show them the chart up here. Oh, way up here. Oh. Miss Anna, I'm really getting my workout today. You have me holding everything with my mouth. Okay, this is called, but don't tell anybody I've told you this, okay? The periodic table of the elements. It just means that everything in the world, in the universe, is made up of tiny little building blocks. And everything has these little things that add up inside them and make different things and have different things in them. Like, there's their spinach. It has iron. And the name for iron on this table is called Fe. We could find it right there. See the Fe? That's their iron. And here's your common salt, table salt. That's NaCl. So that's made up of two things. Na is sodium and Cl is chloride. And it's kind of strange how they put together and there's something else. Oh, there's lemon, has citric acid in it. Even we have fluorine that's found in some toothpastes. Oh, here's the one that's the best thing on the planet. Water, H2O, which means two molecules of hydrogen, which is the very first thing you see on this chart. And then 2O is oxygen. And oxygen, I should know where this is. You see the O, that's OS, and that's osmium. No, where is oxygen? Anyway, it's someplace on this chart. There it is. O for oxygen, and that's the air we breathe. And then there's water, and I'll read you a story about water in just a minute. I just wanted to show you a couple other things. This is your math project for this week, one of them. This is 100 squares, so that's 10 times 10, which is a multiplication problem, because 10 times 10 is 100. All you have to do is take it and fill it in, and then count how many you've used, and that will give you what we call percentage. Another thing that don't tell anybody I said percentage. Percentage. I know you're whispering it. I know. Silas, I hear you whispering it. Frankie, Bodie, Cyrus, Silas, Mackenzie, Grayson, Benyon, Lucas, and Weston, and Soleil. I know you're whispering. Percentage. Okay, so that's something fun to do. And then there's another thing, if your mom and dad get miniature marshmallows and toothpicks, you can make some shapes out of them. Simple shape like a triangle, square. Here is our pentagon, 5. Hexagon, 6 sides. Heptagon, 7. And octagon, just like a traffic stoplight. I mean, a stop sign. 8 things. Oh, and then a 3D box. And this is a wheel. Lots of stuff to do. And on the back is even more. Okay. So, what I want to do now is read a book to you. This book is called Water. Because, as we found out, water is made up of 2 chemicals. H2O. Okay, here we go. Let's see if we can do this. Water. Where is it? Water is everywhere all around us. Here's the next picture. Really beautiful. It is in the air and below the ground. I love these pictures in this book. There is water in the flowers, in the grass, and in the animals and insects. And of course, there is water in the streams, in the rivers, in the lakes, and in the seas, and the oceans. Next picture. What does water look like? Water can be a liquid, like water from a faucet. Water can be a solid. When water is very cold, it freezes, becoming hard, like an icicle. When water is heated very hot, it boils. A gas made of tiny water droplets rises in the air. We call this steam or water vapor. Then water can be a liquid, a solid, or a gas. Pretty amazing stuff. Next picture. The water cycle. We've studied that already, Miss Anna. That's okay, we can talk about it again. The sun's heat constantly draws invisible drops of water into the air. This is called evaporation. If the air is cold and the earth is warm, these same tiny drops gather to form fog. Clouds are formed when the water vapor rises high above the earth. The wind blows the clouds across the sky. When there are many clouds, the sky becomes overcast. The little drops of water vapor in the clouds join together to make bigger drops. This is called condensation. When the drops grow even heavier, they fall as rain. When it's very cold, the raindrops turn into ice crystals and fall as snowflakes upon the ground. When it rains or snows, most of the water evaporates into the air, but some of the rain runs along the top of the ground, and some of it soaks into the earth. Underground, the warm water collects and sometimes bursts out of the land, making a spring. A spring is like a faucet that never turns off. The spring from tiny brooks which run together make streams. When many streams come together, rivers are formed. Some large rivers flow all the way to the seas and the oceans. High up in the mountains, where the snow never melts completely, rivers of snow and ice are formed. These are called glaciers. Like rivers, the glaciers move, but very, very slowly. Rivers of ice. During the summer, the warm air melts the glaciers a little bit, and ice-cold water runs down the mountainside. Some of this water joins the streams and rivers, which in turn empty into the lakes, seas, and ocean. The water cycle begins all over again. Why do we need clean water? Most water is clean and pure, whether it is rain, water vapor, or snow. Sometimes, however, people pollute these clean waters with chemicals and garbage. All plants need pure water to grow. Without water, they will die. Animals need clean water too, whether they live in the water or on the land. People need clean water every day. Even the milk we drink is made of water. All living things are made mostly of water. Without clean, pure water, there would be no life. Oh, look at that man and the dog and the flowers, how much water they have inside them. All right, isn't that a cool book? Okay, before we end this little video, I wanted to show you behind me what I have. This is a chart about simple machines. And I have you going on a wheel and axle walk this week, which I'll show you in a minute. The first simple machine we have is called the lever. A lever can be a crowbar. I'm sorry about the glare there. A teeter-totter or scissors kind of thing. The next is our wedge. The wedge can be an axe, this man chopping wood, or a chisel, this guy chiseling wood, making a baseball bat, or a saw. That's another kind of wedge. There's what it looks like, something that kind of splits something in two. And here is our lever. Looks like a teeter-totter. Okay, inclined plane is just a plane. There's inclined plane down here. That it's like a ramp. You go down, down, down it. There's the ramp. Somebody using it. A moving ramp. Somebody's going up on it. There it is. Or a stairway is another kind of a ramp. Down here. Off. All right, now way up over here is our wheel and axle, which looks like this. So we have a wagon One thing I didn't mention is in the letter I wrote to your parents, the email is the fishing reel has a wheel and axle. And a well does. You probably don't see many of those. That's how people used to get their water. They go down, but they had to turn around and around. And of course, cars, that's what you're going to be looking for, motorcycles. Next we have the screw, which looks like this. Where is the screw? Down here. There we go. Found it. Car jack uses a screw. Light bulb screws in. A thing called a vise screws in, keeps your wood tight when you're trying to work on it. Or a handrail. Or a screw is a screw. Silly, silly. And then we have the pulley. That is our last simple machine. We have, looks like that. So people, mechanics use it. It's called a block and tackle, so they can take the engine out of a car. A drapery pull uses a pulley, and you've probably seen Francisco at school, or maybe Juan when they put up the flag. And right at the top, right here, is our pulley. Okay, so that's it for an introduction into chemistry and simple machines. I hope you enjoyed the presentation.